Hi, welcome to Easy Breezy Math. What I wanted to do today here on this whiteboard is talk a little bit about area, how big something is, how much space it takes up. Whenever I say a concept, I'd also like to give the definition right away so you know exactly what I'm talking about. So again, today is area, how big something is, how much space it takes up. What I want to talk about first when we say area is always measured in something squared units, right? It's always squared. The simple concept for area is always base times height or length times width. Almost think of these as the same thing for right now. Base and height, multiply them, you get your area. Length times width, multiply them, you get your area. Okay, you get how big something is, how much space it takes up. Now here on the board, what I have is the examples that I like to start with when I'm introducing area. What you have up top here is you're just looking at a very simple squares where you're looking for how many squares are in there. This is a concept you can teach elementary school children, I believe. It's real simple. If they can't tell, they can always go through and count how many squares are in there. And then that's the idea. They want to think about having an object squared. This is a 3 by 3. It is in the shape of a square. And all we need to do is understand how many squares are in there. So if I do 3 by 3, I could just count them 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I can get my answer. 3 squared is 9. So when I take 3 and I put it in the shape of a square, or I square it, I get 9. And yes, also you can add in there that 3 times 3 equals 9. Okay? Same thing with another square. I have a second example, 5 squared. I could count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 5 times 5 is 25 squares, or 5 squared is 25. So again, that's how big it is, that's how much space it takes up. Real simple concept, base times height, length times width, that's what we're doing, okay? If I have a 6 by 6 here, I'm not going to count everyone this time, but I think we have the idea. 6 times 6 is my concept here. How many little squares are in there is 36. Now I have a nice simple concept for how big something is, how much space it takes up. Here I have a square. It's a 7 by 7. So 7 squared is what? 49, right? 7 squared is 49. 7 by 7 is 49. Here I have a rectangle, 7 by 11. Base times height, length times width is 7 times 11. 7 times 11 in this case is 77. Okay, and that's my area of that rectangle. That's how big it is in square units. It's how big it is, and how much space it takes up. You can always add in a unit squared here. If it's not, doesn't have an actual unit, you can put that in. Unit squared, it would be, units mean inches, centimeters, all those types of measurements that we have for length, right? If I have a parallelogram here, opposite sides are parallel, right? In our parallelogram, that's what these dashes mean. They're parallel, they go the same way. That's another definition. We can look that up later. But I have the height. I would like to ask here, usually, what's the height of this figure? And so you may have another measurement here. Let's say I did have another measurement here, and this was 9 on the edges, right? And they were both 9 and 9. So the question becomes, what do I use, the 9 or the 8? Now, I wrote the 8 first, so a good guess here is the 8. But you want them to be able to try to figure that out. If I measure my height, I know that I have to go straight up and down from the ground. If I go sideways, I might be 7 feet tall. And no, I'm not 7 feet tall. But here, I want to take a close measurement and recognize that the height is 8, the base is 12. I am going to multiply those again, 8 times 12. That gives me, well, 8 times 12, you can do this faster by going 8 times 10, that's 80. 8 times 2, that's 16. 80 plus 16 is 96. That's right, 96. So that's how big the area would be, units squared, for this particular object, my parallelogram, okay? Trapezoid, now when we get to the trapezoid, this is when everyone likes to have and rely on these formulas. We can get to the formulas, we can do formulas. Formulas are okay, but before we do the formulas, we want to understand what we're doing first. I haven't used any formulas here, purposely. I have not written down base times height yet, because What I want you to do is understand just the simple concept of how many squares are in there and the simple concept of how big something is and how much space it takes up. We can get to the formulas later. So even a trapezoid here, if you can see that, I have the height there. And again, we want to know which number is the actual height, which in this case is the 8. And then I would ask, what's the base of the trapezoid? And I would just ask this question. Of course, most times you're going to say base bottom, and guys or girls are going to say 10. And you'll say, okay, that's fine. That's the base. So I go 8 times 10, right? Okay, maybe. But what if I took this shape and I flipped it upside down to where now the 6 is on the bottom and the 10 is on the top, right? So now the heights, what's the height? The 8. And then what's the base on this one? And then we say 6. But then I go 8 times 6, and that's 48. So then I ask the question, which one will we use? Do we use the 8 times 10 or the 8 times 48? The height doesn't change. This one's 80 and this one would be 48 if we did that. But just because I flip it upside down, does the size change? No, it doesn't. So what do we do? And now you want to give your guys time to think on this one. They think a little bit and you say, okay, we can't use the 6 or the 10, right? Almost a trick question. They hate trick questions. Of course, in math, they think everything I do is a trick question. You're always trying to trick me, Mr. Brown. That's what they tell me. But here, if I take this and draw a line in the middle, or if I were to get that distance right in the middle of my trapezoid, I would have to know that that distance is the same as the number in between 6 and 10. Opposite sides are parallel. These sides are going down kind of at the same angle. Not kind of at exactly as the same angle. And I have to find the number in the middle. So I ask them on a number line, what number is in between 6 and 10? Well, in between 6 and 10, exactly in the middle would be another 8. So for this one, I do have to go 8 times 8. Now, I tell them right away, you can get that number by thinking of what's in the middle, or you can add the 10 and the 6 together and divide by 2. Either way, for this one, you have to find the base, but I'm still doing the same thing. I'm still doing base times height. 8 times 8 is 64, and it would be 64 units squared for that height, okay? That's the way we want to teach that. We just want to know that when we get to trapezoids, and this comes with practice. We practice this all the time, right? This comes with trapezoids. Trapezoids, you just simply have to find the base, but it's still base times height. My concept of area doesn't change for any shape, okay? It's always the same. Here I have a triangle. For triangles, now we go over this too at first. I have my height. What's my height? 8. I have my base. What's my base? 7. 8 times 7 is 56, but this is something I go over with triangles quite often. If I have this square here, and I hope you can see the square down here, and we'll take a look at that, and if I cut that in half, I'll say, is that cutting it in half? Like, sure, you cut it in half, all right. Okay, Mr. Brown, but I'll do it on another square, and I'll say, well, what if I go like that? Did I cut that square or triangle or rectangle? Did I cut it in half? They're like, yeah. But this time when I cut it in half, it formed a triangle. So here, if this was a 6 by 7, let's say, and the whole area is 42, what would the area of just the triangle be? Well, if this is half, it would be half of that. So triangles, we always do the same thing, base times height, but then we chop them in half. And yes, I like to give them that physical representation, chopping them in half. So we always chop triangles in half. And for this one, half of 56, I'll say, what is half of 50? 25. Most people know that because of money and quarters. What's half of 6? 3. Okay, what's 25 plus 3? 28. Okay? Even for circles, and if you've seen my video on circles, you know how I get this circle. And this, again, of course, again, is units squared. You know how I do my circles. If this is 5, okay, then I'll just take another radius here, which is also 5. And to get the area, my area is still base times height. It's just the base and the height are the same, just like it would be for a square. So here it would be 25, but for all circles, when we're doing area, we have to think of pi. So it's 25 times pi, 25 times 3.14, and that would be my units squared. This is a simple concept where you want to do your basic shapes for area. Don't worry about the formulas. The formulas can come later. As a matter of fact, when you understand this, they'll be able to come up with the formulas on their own. Okay? This is where you understand it. When you understand it, you'll memorize it. You'll remember it. You won't have to memorize formulas. You won't have to spend time memorizing formulas. Okay? Thank you.